Oh, missing the square root. No, no more missing the square root. Dude. Aynen. It'll come big. DZ is new, CS is new, A04 is new, DZ2 is new. E is new. E2 is then they're also new, I guess. SE is new. I1, I0 result, okay. Result is a bending energy. Here it's almost 10 o'clock in the evening. Okay, the square of V0 cross A0. The cross product is this, or V2 is the vector that we take the cross product with. So that is the V2 dot x is on the x coordinate of A0. It is probably A0x, so yeah, what we have here. And this is then A0y. And the first one is the x coordinate of V0. And the square of the cross product, I think this is just the cross product. Still need to take the square of that. Yeah, I need a 3. So 4, yeah. Yep. 3, 4, 5, and 6. And a 24. I did it again. I did it again. It was actually faster than not having done that. Two lines? Why would that be 2 lines? Because Unbelievable. One hit. It just works. So good. So yeah, this thing should have a minimum somewhere else. Yeah, I don't print a derivative yet. What to do next? I just feel like printing the whole formula. I want to see the formula. So let's say that print here, D out, DC, notice, comma. And then we print, let's say, the stretching energy. Then we take the arc length and I want a stretching energy. But this gives me the value. But if I just do this, and why not just return the formula? So the quadratic energy, stretching energy without any arguments. I should return a function. Function? Yeah, well, it is a function. Man, damn it. It does make an accessor for it. But yeah, that just prints this. The stretching energy is the stretching energy. Oh, okay. So let's look into my custom IO manipulator. No idea how that worked. It's so unbelievable that I never wrote a good documentation for this. I have sticky and unsticky, and I don't even know what the difference is. It doesn't tell me, it doesn't have a usage. That's too slow. Difficult stuff. How is that used then? Just write it, and then that's, well, that looks what I would call a sticky. If this is unsticky, then what the hell is sticky? Yeah, okay. guess it should be part of symbolic. Let's call the IO manipulator full def for us in full definition. I didn't know I had these PNGs. That's interesting, because I completely forgot how this worked. Cool. Going to look at them. So it looks like this. There's a non-atomic right to the variable A. And then it is sequenced before the non-atomic right to the variable Z. And then that is sequenced before a non-atomic right to Y and a non-atomic, non-atomic read of Y and of Z. But you don't know which happens first, because you could do this one first and then that one or something like that. So it belongs to a program. It's an execution graph or the memory order graph of a super short piece of code. There's a more complex one. This RF stands for read from. So this is the read of X, and it reads from this write to X. ASW stands for, forgot. It's pretty cool. So I wrote a program that generates this. Write a piece of code in C++, and then it generates how the memory model dictates the relationships basically between reads and writes. These are all very simplistic, of course, just tests. There's a more complex one here. That's the beauty of programs, I think. You make it work for simple cases, and then it also works for complex cases. And these are then all the possible executions. So either the memory order means, you know, the order in which things are read and written in the lights of multiple threads, of course. I think this is the main thread that start 3 threads, and then the 3 threads do stuff. And they can do it like this, also like this, or 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 this. There's another one. Lots of possibilities. I think we're around. Yeah, pretty cool. It's actually in tests. So I want to get the full definition of the stretching energy, and that then I should work by writing here full def. That's IO manipulator. Probably have to include that file though. Is that necessary? Kan je go in op board? Symbolic. IO manip full def. Did compile. And then when printing it, that's a print on, right? Currently I get we just get this as output. That is a function, vi function dot h. Just print the name and then followed by the definition, or just skip the name altogether, I guess. So here I must be able to test if the IO manipulator is effective. Guess I have to include that here. I think I just have to call that is full def. Print the full definition. So that should, I think, print every function in full. There it is. So this is the formula. What is this? What the heck is that? It seems like missing parentheses. it not print parentheses around the sum or something when I square it? Yeah, it does seem to work. You can have parentheses around that. It's also strange. Maybe not. I don't know. There you already have it again. Something squared and then immediately that's silly. Squared and then the square root. It's actually pretty short. I mean, before this formula was 10 pages long. And now it's suddenly nothing. Well, almost nothing and compared to what it was. So impressive, I think, that it was able to keep it this small. I mean, we know that it works because the values are the same. So this worked, and then there's a completely different way. And again, so because the values are the same, it's just working. So it must be the correct formula. A month page. No, this is just my stretching and energy formula, calculated by my code. Because I didn't want to type all this. I spent a whole month symbolic programming and stuff. I'm just wondering how and if I want to test this missing parentheses thing. I guess I just have to test it real quick. Looks like a sum. Let's say you make an expression. How did that work then? It's just printing. Maybe. I think it has to do with. It has to do with the fact that they are functions, I think. Well, let's test it anyway. So we would just have an expression of, say, I don't know, this expression. X plus y to the power 2. And then all to the power 2. No, 3, so I can recognize. And then I print that. See that then the parentheses are just there. I think the problem is in the printing that I just changed. Function.h. Could print a parenthesis around the definition. Yeah, that must be it. I got a lot of those things. So maybe too many, but yeah, better too many and too few, I think. No, awesome, cool. And I can even print, say, the. Let's see. Yeah. Let's print the derivative of the stretching energy as a full definition. You have to pass the symbol now. Arc length, that's something. Just make these things public. At least the symbols then. At least these symbols then. Oops. So derivative relative to that symbol. Okay, now we have a long formula. See how fast this blows up? That's why I wrote that library, because you don't want to do this manually. So the derivative is this formula. That's even the derivative of a single variable. And I have two variables. Pretty awesome. What to do next? In the end, I need the formula for the total energy. Energy. The bending weight, probably a constant. So we redefine this. Symbolic constant reference bending weight. I'll just take something is constant realize 100, and the total energy I can solve it as a function, I suppose. I think yeah, it's not working. Don't have a plus equals. Can make it total energy, but it's a reference, so we have to do immediately assign it. Let me see. It's more like the energy of 0, 1. And I can only access it in this scope. I'm just gonna, let's do dirty and make a pointer or something. Let's call it energy 0, 1. So I'm gonna make a symbolic expression const pointer energy 0, 1, and the other one is called what? 1, 2, I suppose. Yeah. 1, 2. Energy 0, 1. So here I have energy 0, 1 is and then I have to use the quadratic stretching energy, which is this one, but as formula. So arc length, arc length stretching energy plus binding weight underscore times arc length bending energy which then gives me a reference, but I want a store pointer, so whoops. I don't have a quadratic thing here yet. It's called arc length, I guess. Wait a minute, where's that done? Inside create quadratic from, and then we do this. Quadratic from, find a new arc length. It's actually not arc length, not the right word. It should call it energy or quadratic energy or whatever. And this one is created from the 1, 2. And then I can assign energy 1, 2, pointer 2, the same thing. And then here I can create the total energy function. Yeah. That evaluation depends on the assignment of all angles, which I haven't done at all yet for this one. Hell, I destroyed that object. Not good. Not good whatsoever. Although I actually probably doesn't matter that I destroyed this object. It's all stored in the cache. And the cache is an element of the object. Don't tell me that's true. No, it's of course not. Oh, nonsense. Sorry. It's just not working. It's definitely not working. It's not working because this one has symbols with the same name as the other one. And the symbols, they are looked up, I think. They are hashed by their name. So they just share the same. They share the same hash, and they end up at the same place in the cache. Should give these a different name. But then what happens with this? Is a function hashed by the name? I think the name is part of the hash, but it's not really determining it. Is it? Actually, it is, because it's the hash of the function is determined by the fact that it is a function which is constant, and the name, and the definition, which gets its hash from... no, in the end it gets a hash from the... I think the hash of the variables. So probably should have a different, different hash. It's not clean, totally not. Okay, let's rename these things to _12 and see if it holds. Oh, wait a minute, that's nonsense. Let's just have the same object. Suppose you could pass some kind of postfix to the quadratic energy, which you don't add there. I've got something here. Closing parenthesis. Mm. What this happens when printing the new total energy? Let's try printing the things that I just added or am about to add. Yeah, they loop like this. 100 times the bending energy plus the stretching energy. So you see that every variable is prefixed at 0, 1. That's good. That's actually what I want to see. I want to just right. Print the full definition of it. Seems to work. So the energy 0, 1 is 100 times something that has a lot of 0, 1 prefixes. And then the energy 1, 0 is the same thing, but then with the 1, 2 prefix. And then adding them gives a problem. Interesting. Can't add them. Why not? Why would I not be able to add them? That is completely different things. Using different variables. 100%. Why is this going on? Let's run it in the debugger. See if we can get a vague idea here. Tau both functions. They have different hashes. Bending energy. Yeah, okay. I guess bending, it's the bending energy of the one and the bending energy of the other one. But because the name is the same, it's treating them as the same thing. And I think I now understand why that happens. So that would have to do with less compare, probably, of symbols. Which is totally using the name. So the case of functions, I should maybe use the hash instead of the name. Am I using the name of functions? They are the same. Combine. Argument 1 of sum 1 and sum 2. Yep. That's exactly what we are doing. What? Oh, next. No. I can still list. Is less. Yeah. Choosing is less. What happens if you use is less on two functions? To be honest, I have no idea. Damn it. This was in some. Some.h or not. Symbolic is less. It's not defined here. I have to go to binary operator. Define. Well, no, not. It's a bloody template. Good. So we get here is same. OPT in sum, yes. Return is less exact. Get non-constant vector. Okay, now the non-constant vector of a function, it's probably just the same thing. Just this. Yeah. This we call is less exact on two functions. Now we get here. Is it a power? No. Therefore we get here, and I get the type, well, which tells it that it is a symbol. Functions have a symbol as their type. So the types are the same, and not unequal. The type is not a constant, the type is a symbol. Therefore it returns symbol 1 is less than symbol 2. After having cast a function to a symbol. Ouch! Ouch! Yeah, and that is not good. That totally not good. Undefined behavior. Cannot cast a symbol to a function to a symbol and then compare them like that. Suppose I need to make a function type, so we can fix this here. Oh, it's hardly used anywhere. Let's just add it. Function type. Well, this then has to be 2, I'm afraid. Which means I better shift this up 1 place. 2, this 2 must become there. Binary operators. Is this the binary operator? Yep. The unary operator is this one. And then it must increase in size, so this could be just 0. In value, I mean. These must all be 0. What is this? Binary op again. This must be 0, 1, 1, 0. 0, 1, 0, 0. 0, 1, 2, 4, 5, 8, 9, well, 10, and 11. Yeah, this can be anything. This way it becomes larger and larger, right? So again, this is the binary operator. No, it's not set here. It must be a 1. Yep, this was the unary operator. Okay. And this one is that set because it must be larger than everything else, so it might as well be 0 then. 1, 2, 4, 8, 16. Okay. And unary up is 4. But no, it's now 8, I think. 1, 2, 4, 8. This is 8 and this is 4. Yep. Yeah, okay, function has been added. Right, so let's sort these things by guest hash. Hey, a post bunny is there. Well, was anyway. I only see it now. So let's just compare the hash. Oh shit. Total energy, not a number. Shit. Why is that? It should have been this. Okay. Oh, it's not a number because I never assigned these variables. Yeah. That is still a problem. Where does this happen? Probably here. It's not print these anymore. Evaluate, yeah. Evaluate, yeah. Kind of have to assign those variables, which is kind of problematic because I destroyed the objects that have them. To mention that I wouldn't have any clue. Let's see, generate rejections. Can't do this while generating rejections. Continue. Successful curve, but then we do have an else. And this is where I have those things. So I should not even be doing this while generating rejections. There is an else here, which is done, generate rejections, and then here the same thing. So you copy this. Let's only do this while not generating rejections and do I even know what the angles are? Probably. I think that the angles are, for example, that angle. Yep, they're still defined. Quadratic form. And here a quadratic form. So before I do the evaluate, I have to assign these things to the appropriate variables. Which means I have to recreate the variables here. I think I can do symbolic symbol. const reference. And then 4 times. And then use the same name as I have inside these things. Because these still have the correct value. Actually, even these have the correct value. What do you mean still have the correct value? What is defined by, yeah, this assigned by the constructor, so that is, but these I never have assigned for the 1, 2 case. Let's just do these then. Name prefix V01QA. Can't prefix it with that. Let's postfix it. What? Maybe not use is not correct. Unused. Okay, unused. still not a number. Shit. Huh? Maybe should evaluate all the variables that are used first. The whole point is to know that these things have a value. I think a symbol has a realized where I pass a value. Does that not work? Symbol, is constant, function, symbol name, symbol value. It is then used for the constructor, so the value is immediately set to the value. Okay. Oh, except that I'm not using it when I find it in the cache. Yep. Yeah, the whole construct is nonsense and should not do that. So this realize can also be removed then. Yes, the correct value. Okay. Now this is interesting because now I have a total energy here. So if now I change, say, this angle, then 0 is definitely not going to be the minimum. Yeah, so now it's 195,302, which is not 0. Well, not minimum anyway. So, but making it like this, so it becomes almost infinitely large, is also very big. Now is it 65,565, which is suspiciously. Well, anyway, the minimum is 8,000, 2,000, 1,000, 1,400, 800, 700, 700, and larger. 785, 783, 783. So somewhere here's the minimum. So this, in terms of this angle, is this the optimum between bending energy and stretching energy? Not a straight line. But the total energy is for both curves at the same time. So if I change this one, then both curves are changed. So that should allow me to drastically reduce it. 300, 200, and that's more again. 2, 4, 5, 245, 245. Something like this, 245 something. And that is because this angle here points down. Of course, if I move this one such that it points up, then this is going to be a lot less. 2003, less than 100. 96, 91, 86, 72, 68, 61, 58, 55, 54, 53. Now it gets larger again. So 53 is like the smallest. Let's see, 53 something. And yes, that is, as I had sneakily expected, the bisector of this angle. So now it would be interesting to print the value of the derivative of the total energy with respect to this angle. Then that should be 0 when the angle is at this value. And then the next step is that I can automate that, I suppose. So let's stop printing those huge formulas. Just in this huge formulas are printed where? Here. No, that's evaluate. I just create this thing here. Okay, wait a minute. Let's first give it a different name. Substitute. Quadratic energy objects. So I just created from the Bezier curve. This prints the formulas, I think, but not full. Must somewhere have a full diff. Let's comment that out. Where are the? Oh, here. I think that's a huge formula that I was printing. But yeah, this doesn't make much sense to do. Anyway, the quadratic energy object is only used to get the formula into energy 12, but the formula doesn't change. The formula is the same. So this thing here that is done over and over and over again, it's only necessary, or it's not even really necessary, but yeah, well, it's necessary to copy the values of the Q and N. So if I start dragging points, then it is necessary to redo this, but otherwise it wouldn't even be necessary. So this is, yeah, burning a lot of energy. So burning a lot of CPU. That's kind of not necessary. But so is this. Let's just print a derivative of the total energy. With respect to what is actually slightly problematic. I think I'm using two different arcs, although they are linked. These two are linked. Should I have only one variable for them? No. Are they exactly linked? Not exactly the same, are they? Nope. The one of the green one and the other one's the red one. So they're different. They differ a fixed angle. Why is that so slow? Derivative is just printed like that. I didn't add the evaluation of it. feeling I should remove the name of the function from the hash. So even two functions with a different name but the same definition, it's just the same function. Anyway, let's write the evaluation of that thing as well. Evaluate. Damn it, man. Let's just do it. Not hash the name. Mysteriously, I get an assert as a result of that. It's doing it again. So fix an equal bug before. Quit. This must also be a multiply. Because it kind of makes sense. See, you can spot more of those. Or make product that takes a multiply. Suspicious. Yeah, for example, this multiply probably, might become a constant, in which case we have a problem. So I'm just going to use multiply instead of make product. Slowest, but it's functional. Now we have a negative value here for the derivative. Let's see what happens to that if I change it. Imagine me dragging stuff. It's pretty slow in calculating that. Yep. Oh. Yeah, what? Very big. Very big still. Thousands. 385, 11, 53. Yeah. Yeah, not very useful. I need to have the value relative to it's kind of strange though. If I take the derivative of only the green angle, that means that the red angle stays the same, which means that this thing doesn't change. So you get a nick here or a bend, sudden change in angle. So it should give me the hello there. I have no idea why YouTube does that. Are you coding in C++ or otherwise interested in difficult things? It's so slow, man. It's still only 24. 25. 22. 17. 5. 0.33. Wow. Oh, there's a minimum here. 0.03. Wow. Strange. Strange. Zero point 0.03, I said. Well, it was 1.03. So the line is too long. There, now I can read it. Sorry for everyone else. Negative. Yeah, that's also possible, of course. It's still around here somewhere. 1 pixel further and it jumps. This angle is still the minimum. Well, no worries, because it's time for me to stop, which means that I'm not stopping but going to play chess for today. Let's end with some chess game. And I keep playing d4. Well, I can't. Well, I don't even know any opening theory at all with d4, but that's why I started to play it. I need to learn it. Why are you attacking my knight? What is this bullshit? Now I have to pin your knight. Seriously. Seriously. I get a free knight. Very nice. What is this rating? 2000. I must miss something. What am I missing? I'm not missing anything. Oh, I do this, he takes here, and then my knight is pinned, and then I take with the queen. No problem whatsoever, dude. What is his problem? Then this knight comes out, and I go back again. Or here even. Oh, he takes. I have to take with the queen, and the knight comes, forking my pawn and my queen. And I can't really go anywhere without giving away my pawn then. Is that true? No, because the pawn is here. I could go there, for example. And then he could put his knight there, attacking my queen again. And if then I take a queen, he takes my queen. That's no fun. What about I take, he takes, I take a knight, he takes my knight. I take here, he takes here, check. That's horrible. Okay, I don't want to go for it. I trust this guy's rating, as it were. Now I'm definitely threatening this, but not anymore, because he moved the queen. Yeah, plus my bishop is not defended. So if now, say I put my queen here, and he takes, and I take, then my pawn is in, queen defends that. Okay, I go take, 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 and I lose my bishop. Whoa. So I first take here, he takes here anyway, and can't even put my queen in front of it. Ouch. Yeah, this is like a double attack on those 2 pawns. If we go back, he just takes the pawn anyway. Ugh. Suppose I do this, he takes, I take my bishop back, he takes there. Also not good. I go here, he takes, I push, then I put it back, then he takes. I'll rather give away this one. I want to defend this pawn, but not with the bishop. I think I have to defend it with the queen. I'm so going to lose on time like this. Oh, yeah. That seems like the correct thing here. Now he's attacking this again. Twice. If I take here, he takes. And then my rook hangs. Yeah, my queen was defending the rook. So this was not good. If he takes with the... I'm so fucked. Oh, I'm so fucked. No, he's one pawn up and 4 minutes. Oh, why not a free pawn? Push this. I can't push it immediately. Oh. Yeah, what can I do about it? Absolutely nothing. See, you're 2 pawns up in the meantime. I gave away a rook, but he didn't see it. That's interesting. Well, did I give it away? Yeah, I gave it away. I did give it away. If now I go away, get check and lose this pawn as well. Just 100% lost. 100% lost. All like that. Okay, I resign. This guy didn't even use. He used minus 15 seconds. Jesus Christ. That makes me pretty depressed, as it were. Try d4 again. This time against a 1910 player. The why not move? Let's have two connected pawns. This pawn maybe? Whoa! Whoa! Really? I have to think about this one. I feel like doing this. I don't believe that. Yeah, what? That was clearly mouse slip, so I offered to take back because don't want to win because someone Lamza's mouse didn't work very well. Now it looks like I did a take back because I think I went anyway. I'm not sure if that's the case, really. Not at all, actually. Let's see. Yeah, I kind of have to take it. Defense it like 3 times. I attack it 3 times. Take. Ooh, no, that's not good. I ain't good at all, man. Let's go here. Give away this pawn. Okay, so I go here, he takes, I go there, threatening something, maybe? Come on, this must be winning. Gonna try this. Going to try it. I need like 1, 2, 3 moves to get my rook in. I can also use this maybe. Slower. This. That's also 1, 2, 3. You can just lift the rook and then go there as well. I guess 3 moves is not really enough. Why he goes there? I can give check. Nah. Rook here, I'm dead. Ish. This is horribly defended, man. Horribly defended. That is a wrong move. No take back. Oh, I can go here. No, it doesn't matter. I just win equality. I just win equality. Yeah. +1. So I lost a pawn somewhere and I won equality, or... Yeah, I should have gone here with a knight. Threatening a fork and attacking a pawn. That would have won. Another pawn. Can still do it. He takes here, costs a pawn, I win one back. Can still do it now? Not really, because this one is defended. Plus it's not a fork threat anymore. What am I talking about? Go here though. No, it's still defended. I need to chase that knight away. Not possible. Now I can do a double attack again on 2 pawns. This is good. This is good. Double attack. Actually, not that perfect. I go here, do that, I go. Oh, well, it takes there, and that's horrible. No, cannot allow that. Yep, thought so. Well, might as well go here. Rook lift. The rook has been lifted, yes. That's a pretty damn annoying piece of knight there. Oh no. Fortunately, I have this move, which is pure luck, I admit it. Check. Let's give check first. Yeah, I can defend the... No, I cannot. Cannot defend the rook. So now I have the rook and the bishop attacked at the same time. You can take there. I'm still 1 pawn up now. Let's start walking, why not? Is this a draw? Well, it's already covered. He's almost there. Like 2 moves. I need 1, 2, 3 moves. It's a draw. Let me just give the rook. Let me see. How do I give my rook? Like this. It's no fun. Take, take, move. Oh, looks like a draw. Yeah, okay. Okay, let's stop the stream. I'll be back tomorrow, peoples.